Hey guys, hope you're doing good. This is Shiva Science studying at Sri Venkateshwara College of Engineering, pursuing my second sem in the Department of Artificial Intelligence. Today we are going to be discussing about the corrosion in chemistry. We are going to be discussing about what corrosion is, the causes of corrosion, impact of corrosion on engineering, preventing corrosion, corrosion testing, monitoring, future of corrosion prevention, and conclusion. What is corrosion? Corrosion is the natural process that occurs when materials interact with their environment. It is the gradual destruction of metals, plastics, and other materials through chemical reactions or physical wear and tear. There are many types of corrosion, including rusting, pitting, and galvanic corrosion. Rusting occurs when iron or steel reacts with oxygen and water to form iron oxide, while pitting is caused by localized damage to the surface of the metal. Galvanic corrosion occurs when the two dissimilar metals come into contact with each other in the presence of electrolytes such as salt water. Causes of corrosion. Corrosion is a complex process that can be caused by a variety of factors. One of the main causes of corrosion is chemical reactions, which occurs when metals come into contact with substances like acids or salts. For example, when iron reacts with oxygen in the presence of water, it forms rust. Another cause of corrosion is environmental factors such as exposure to salt water or humid air. Physical wear and tear can also contribute to corrosion as repeated friction or impact can weaken the protective layer on the metal surface. Chemical reactions aren't always harmful, however. In fact, some metals are intentionally corroded to create a protective layer that prevents further damage. This process is called passivation. Environmental factors can also have positive effects on corrosion prevention. For instance, some metals like aluminum form a thin layer of oxide when exposed to the air, which protects them from further corrosion. Understanding the various causes of corrosion is the key to prevent from the occurring of corrosion in the first place. Impact of corrosion on engineering. Corrosion can have a significant impact on engineering, with negative impacts or effects ranging from reduced efficiency to safety concerns and increased maintenance costs. For example, in the transportation industry, corrosion or steel bridges and tunnels can lead to structural damage and even collapse, putting lives at risk and requiring costly repairs. Similarly, corrosion in oil and gas pipelines can cause leaks and spills, resulting in environmental damage and expensive cleanup efforts. And in the aerospace industry, corrosion of aircraft components can compromise their integrity, leading to catastrophic failures during the flight. These are just a few examples of how corrosion can have serious consequences of engineering. Preventing corrosion. Protective coatings are one of the most effective ways to prevent corrosion. These coatings act as a barrier between the metal and the environment, preventing moisture and other corrosive substances from reaching the surface of the metal. One example of such successful prevention strategy using protective coatings is the use of epoxy coatings on offshore oil rings in harsh marine environments. Cathodic protection is another method of preventing corrosion. This involves connecting the metal to the protected to the sacrificial anode made of the more reactive metals such as zinc or magnesium. The anode corrodes instead of the metal, protecting it from corrosion. An example of successful cathodic protection is the use of sacrificial anodes on ships to protect the hull from corrosion. Corrosion testing. Corrosion testing is a crucial step in preventing the negative effects of corrosion engineering. By identifying potential vulnerabilities, engineers can develop effective prevention strategies before damage occurs. There are several testing methods available, including salt spray testing and electrochemical testing. Salt spray testing involves exposing materials to the corrosive saltwater solution to simulate real-world conditions. Electrochemical testing measures the electrical activity of a material to determine its susceptibility to corrosion. Corrosion monitoring. Corrosion monitoring is an essential aspect of any corrosion prevention program as it allows for early detection and intervention before significant damage occurs. There are various methods of corrosion monitoring, including ultrasonic testing and visual inspection. Ultrasonic testing involves the use of high frequency sound waves to detect changes in metal thickness, while visual inspection involves a physical examination of the metal surface. In real world scenarios, corrosion monitoring has been used to prevent catastrophic failures in structures such as bridges and oil rigs. For example, in the case of the Golden Gate Bridge, corrosion monitoring allowed for the detection and replacement of corroded rivets before they could cause significant damage. Similarly, in the case of offshore oil rigs, corrosion monitoring has been used to detect and repair corroded pipes before they could rupture and cause an oil spill. Future of corrosion prevention. Emerging technologies and strategies are providing new hope in fight against corrosion. One of the most promising developments is the use of nanocoatings, which can provide a high level of protection against corrosion while being extremely thin and lightweight. These coatings are made up of tiny particles that form a barrier between the metal surface and the surrounding environment, preventing corrosive elements from reaching the metal. Another exciting area of research is advanced monitoring systems, which use sensors to detect changes in the metal's properties and alert engineers to potential corrosion before it becomes a problem. While these technologies are still in their early ages, they hold great promise for the future of corrosion prevention. As we continue to develop new materials and methods for protecting our infrastructure, we can look forward into the world where corrosion is no longer a major concern. So I hereby conclude saying that corrosion is a pervasive and costly problem in engineering that will lead to reduced efficiency, safety concerns, and increased maintenance costs. We have explored the various causes of corrosion, including chemical reactions, environmental factors, and physical wear and tear. We have also discussed the methods for preventing corrosion, such as protective coatings, cathodic protection, and material selection. Additionally, we have examined the importance of corrosion testing and monitoring, and looked at emerging technologies and strategies for preventing corrosion in the future. Thank you.